Okay, so we're talking about acids and bases and theories of naming acids and bases. So acids always have aqueous as their state, and they always have a hydrogen. Okay, so our rules, these are found in our data booklet, but just as a review, if the second term ends in "ide," it now becomes hydric whatever with an ic at the end acid. If it ends in "ate," it becomes ic without a hydro, and if it ends in "ite," it becomes us. Okay. So, for example, we need to change each of the following into the appropriate acid name in the given formula. So, hydrogen iodide will become hydroiodic acid with the formula just HI. Okay, hydrogen phosphate becomes phosphoric acid with its equation of H3PO4. Hydrogen nitrite becomes nitrous acid at HNO2, and hydrogen sulfite becomes sulfurous acid at H2SO3. Now, most bases are ionic compounds that are named accordingly. So, to name each of the following bases, so these are all bases, and just we name them our normal way, okay? So, we have sodium hydroxide, sodium hydrogen carbonate, and magnesium hydroxide, and the famous ammonia. Now these are different to IUPAC names for acids, and these are simply the word aqueous followed by the ionic name. So naming each of these becomes quite easy. So if it's hydroiodic acid, okay, it's aqueous hydrogen iodide. This is again just our simple ionic names, and we put aqueous in front of it. So magnesium hydroxide becomes aqueous magnesium hydroxide, sulfurous acid becomes aqueous hydrogen sulfite, and sodium hydrogen carbonate becomes aqueous sodium hydrogen carbonate. Okay. Now, if we look at properties of acids and bases, empirical properties are observable properties of a substance. Acids, bases, and neutral substances have some properties that distinguish them and some that are the same. So, let's look at these properties, shall we? So we have acids, bases, and neutral substances. Okay? Acids are sour to taste, whereas bases are bitter to taste. Okay? Acids are electrolytes, bases are electrolytes, and neutral substances can be electrolytes or non-electrolytes. The important part here is that both acids and bases are electrolytes. Okay? Acids neutralize bases, and bases neutralize acids. Okay? Acids react with indicators. Bases also react with indicators, but neutral substances do not. Okay? So, litmus if it's an acid, litmus turns red. If it's a base, litmus turns blue. Okay? Bromoethanol blue turns yellow if it's an acid, and blue if it's a base. And phenolphthalein is colorless if it's an acid, and pink if it's a base. So, acids react with metals to produce hydrogen. Okay? They have pHs of less than 7. Bases have a pH of greater than 7, and neutral substances have a pH of 7. Okay? So some examples of acids is HCl, H2SO4, bases, we have anything with hydroxide on it, as well as our famous ammonia there, and then we have all of these different neutral substances, which are essentially just ionic compounds that are aqueous. We're going to talk about Arrhenius and his definitions in the next video.